The last part in your brief introduction to R is dedicated to statistics, shortly stats. Among my students, I heard once in a while this alarming comments that I hate stats or I don't understand stats. And this still puzzles me why some students have these attitudes. Let's answer the question why you need statistical tests. You get some numbers, and numbers prone to noisy variations, and you might think that you found some differences compared to some references, but it can be simply by chance. And this is the thing you cannot solve yourself without some extra help. You spend days, sometimes nights in the lab, you do some experiments, you fill your lab book and then say, hey, I see a difference, I have found something incredible. Nobody described it before. But if you don't use common sense, statistics, and thorough check how and what did you do, it is possible that you don't have this effect. It is possible that no one else on Earth will reproduce your data. And know that biological data suffer from low reproducibility in general. Therefore, again, you need statistical tests and statistical analysis. But do you need them all the time? No. You don't need statistics if you say that sun is hotter than the moon. If you accept that sun is a star and moon is another planet, then it is to a common knowledge that stars are hot and planets are not that hot. They cannot be so hot. Statistics will help you, like Lady Justice, to deal with the numbers. It has some tools of testing for significance, what's right, what's wrong. But of course, it is a little bit blind, and therefore there are some problems abusing statistics or not using it properly, which is not for the beginners. So for the beginners, it's better to follow some general rules and stick to them. How it works and where it works. First, of course, you still have to collect the data, then prepare your data tables. Then, depending on what you have, for instance, if you have a groups comparison or two lines, you have to check the books and find out what kind of tests will serve the purpose and what is your question. For instance, my question is whether group 1 is different from group 2 by some particular measurement. So you take the test tells you the p-value. You still have to spend the time describing the effect, how big it is or small, and then you make your report. Remember that p-value is not all you need to do in the report, although p-value is the major result of your statistical tests. And also remember that p-value simply means how likely that things you observe occur by chance. Where to find tutorials? Of course, in the books. So the best help is always in the books. But if you don't have a time or if you don't have a book, then online you can come, and with biological background, you can go to STHDA. You can come to STHDA for many reasons. That first, it is about high throughput data analysis, meaning gene expression, something like this. But also it's full of examples for R programming language. Then, of course, very basics are described in a quick R in a chapter statistics. Then for the first time, I would say I would give a reference to YouTube. There is a site StatQuest with Josh Starmer. I like it. It is indeed short and clear. Lots and lots of videos about basics of statistics and around it. Very nice. I wish I could do the same. No, not the same, but the same level. Well, let's continue. When you do analysis, you come to the categories of the tests. One is called parametric and another category is non-parametric. What it means that parametric tests, they rely on a data distribution which is usually a bell shape, that's why the bell. And non-parametric can be compared to the flipping coin. In this case, there is no assumption of a data distribution, and therefore, if you are in biology or this sort of the business, you have to check, preferably in advance, how likely data will follow bell shape on average. For instance, weight of some or height of some particular population in particular country is probably centered around the average, and therefore it is appropriate for the height comparison or weight comparison what is happening with the checkup of babies. For instance, they are measured by length, by weight, and then doctor says, oh, he is quite good in the average, or he is above the average, or we worry a bit this young individual is a little bit below the average, she should eat well. And some other data are not bell-shaped at all. For instance, age of the population might be very far from a bell shape, and therefore non-parametric tests might work better. And for the beginner, there are many more cases, but there are two major cases at the beginning. Is the group statistics, where you have a big population of individuals, and then you select a group of, let's say, those who have a mustache and those who have not, and then you compare something, head color on their heads or something else. This is called group statistics. It can be illustrated as a series of box plots of boxes with the means and highs and lows, or you can compare what's in common between A and B, or you can do 2 by 2 table exact Fisher example. So it's not necessarily one t-test all the time. Everybody lean on t-test. The tests are different, but overall it is a group statistics answering the question, what's the difference and whether the difference is significant, or is it, in this case, this case is similarity, not difference. Is it by chance or not? And another group is the trends. How well it fits to the curve, something you measure. And in this particular case, there is a word appearing, model. So there is some model equation behind which would explain or not explain your data. And then how well this model describes your data, that's a question. The data for your exercises are your own, or if you don't have a good example, check our data sets I showed you before. Very good collection of not too complicated data. Sometimes, especially because you know already that p-value is about the same thing happening by chance, you can directly check what is happening by chance using randomly generated data. There are two basic generators in R. One is R norm. It generates a bell shape distribution, and a flat random run if, where highs or lows or in the middle, they're all flat.